Yeah. So hi everyone. In this video, I will be explaining about my FA2 submissions, where we will be creating a case study on a project that we have created for me in this case, which is an edtech platform, and what are the different design patterns I have used in order to make my project more code efficient. Now, before diving into the actual assignment, I would like to give you a brief introduction about the design pattern that I have used. For creation pattern, I have used a factory method here. For structural pattern, I have used the adapter pattern. And for behavioral pattern, I have used the observer pattern. Now, design patterns are nothing but solutions to an existing type of problem that we face in regular basis in the coding environment. For example, the creation patterns are mostly responsible in order to handle the creation of objects depending upon the complexity in the instantiation process. For example, there are multiple creational patterns such as factory method, singleton, and builder pattern. Then comes the structural. Structural pattern deals with the organization and composition of the classes and objects, uh, which help in establishing the most efficient ways to connect between the components, and structural pattern basically enhances the code readability and reusability. The main purpose behind the evolution of design patterns is to establish a sort of efficient way so that we can improve our code readability and reusability. These are the two main component for the uh, design pattern. Then comes the behavioral pattern. Behavioral pattern are nothing but the are used to find the most efficient way to address the communication between objects and dealing with how the object interact with in order to fulfill the responsibilities collaboratively. The examples of behavioral pattern are observer, strategy, and chain of responsibility. Now, the first pattern that I have used in my project is factory method. Now, factory method is nothing but as we have seen here, it is a creational pattern which deals with the creation of objects. Now, for an edtech platform, there might be different type of courses such as either the courses might be a self-paced courses, instructor-led courses, or the certification courses. And with the help of the factory design pattern, we have the extensibility easily add the new course type, and we can encapsulate different private methods with the help of which we can facilitate the better code readability for the users. Now, since from this diagram we can understand that we have created an interface course which can be extended to different type of course, so that whenever we need to add a different type of course, we can simply we can simply inherit we can simply implement the above course interface and perform the necessary changes, and depending on it we can decide which type of course object we need. Now, as we noted, every course comes with a con, so there are some uh, disadvantages that factor method has. First is the complexity. Since we are adding more classes, potentially it increases the complexity of the project. Secondly, subclassing. It requires a subclass for each new product type. As we have seen, we need to create a subclass for each separate project, each new course. Now, since I have used the TypeScript as my primary language in order to show the demo codes, we have created an interface of which has a method start course. Then we have implemented this method for the self-paced course instructor courses, and we are implementing the same method in each function. And later we are deciding, depending upon what type of course we want, we are simply creating the object of that particular course. And here we can decide which type of, and here we have a factory course, create factory course here, which will decide depending upon what type of course we need to create, we need to call which particular method of the respective class. Second is the adapter pattern. Now, adapter pattern is nothing but a way in which we can make the two incompatible things may communicate with each other. It simply acts as a bridge between two incompatible interfaces. wrapping an existing class with a new instance. Now, for example, in a network platform, let's say for the payment gateway, we have a multiple payment option. For example, Razorpay, PayPal, Stripe, or let's say PhonePe interface. We can use the adapter pattern here in order to make our code more reusable, and we can increase the interoperability of our code. But since there are a few disadvantages that it has, that is first is the complexity as it adds an extra layer of interface for each particular instance of class. And secondly, we need to have a proper maintenance of each particular interface and each particular class if the API changes. For example, here we have created a interface payment adapter. It has a method which takes amount as a number and returns out type word. Then this class is particularly implemented by the payment gateway, and now depending upon which particular method of the class we have uh, we have implemented each method in a payment adapter interface. Now we have a function process payment which simply takes the adapter and the amount. Now depending upon what type of adapter we are getting here, we can simply adapt to any new payment method that we have. Now, since this is a mock implementation, we are not actually going into the actual implementation where API calls have been done for the actual payment with the bank servers. This is just a uh, bird eye view understanding about how the adapter pattern might work for different scenarios, or how the factory pattern might work for the different scenarios. Uh, Thirdly, but not lastly, it is an our observer pattern. The observer pattern establishes a one-to-many relationship between objects where we one object or subject uh, changes state. It notifies all dependent objects which automatically updates. Now, with the help of observer pattern, we can facilitate loose coupling between the sorry with the objects. And secondly, the observer pattern basically helps us to build scalable architecture. Build us to create a really scalable architecture. And secondly, there are few disadvantages that we also have. For example, if we may introduce Slack, there are many observers, and secondly, it requires a lot of there is the mock implementation of the observer pattern. We have created an interface. So interface are the most core component of any design pattern. So in order to understand the design patterns, well, we surely need to understand about the interfaces and abstract method and the OOMD concept basically. Yeah, so we have created an interface for observer and it has a method update which takes the message as string and returns a type void. Now, depending upon who is using the class, so let's say student is using, we will implement the method and we basically implemented the all the abstract method that the interface has. And secondly, we have created a class course which has an observers which is an array of objects which is initiated an empty array. And secondly, we have a multiple method which is attached, detach, and notify observer, add lessons. Now, depending upon which type of, now we have also created a student. Then, depending upon what we need to do with that particular student, we can simply course.attach with the help of method. We can append our student one into the observers array. And secondly, if we want to remove any particular student, we can do it for again. So yeah, this is nothing but a simple bird's eye view understanding about the different design patterns and how they can be implemented. Yeah, that's it. From my side. Thank you, Anthony.